Hi everyone. So in this video we are going to be finishing up our discussion on demand. Last where we left off, we just finished going over the demand schedule, but remember that there are three different ways to model demand. So, last time we covered the first one, just the demand schedule. In this one, we are going to finish up by um, going over the demand curve, and then afterward the demand function. Okay, now the next way to model demand is the demand curve, which, as I said from before, is just a graph. So what I'll actually do is I'll use this information right here, right? The same information that I just put down in the table to graph the demand curve. So, um, an important thing to note about the demand curve. So it's going to be a graph, right? Which means there'll be an x-axis and a y-axis. But I'll say here that it's convention in economics uh, to always make sure that the price of the product is measured on the y-axis. And the x-axis always measures the quantity. That's not due to any uh, logical reason. Um, you could flip it. Like in theory, you could flip it so that the x-axis measures the price of the product, and then the y-axis instead measures the quantity. And that would be perfectly mathematically and logically, that would all be perfectly valid. But because when Adam Smith, who's considered to be like one of the fathers of the modern economic way of thinking, when he first drew a demand curve, um, he did it like this, where the price of the item was measured on the y-axis and the quantity of the item is measured on the x-axis. It's always just kind of like followed that type of convention. So again, logically, there's no real reason for always doing it this way. Mathematically, it would still be perfectly fine if you flipped it. However, because this is the convention, we will stick with it. To always measure the price of the item on the y-axis, and the x-axis will always measure the quantity. And it's not like logically, again, like logically it would make sense if you flipped it. But as we get into some other models later on, it will end up being the case that I'm teaching it according to convention. So it'll be easier to understand as long as you get into the habit of measuring price on the y-axis and quantity on the x-axis. So it'll just be easier in the long run, as long as you get into the habit of doing it like this. So that's what I will be showing you, and that's how I recommend you do it as well. As a matter of fact, on any questions where this will end up being relevant, I will actually deduct points from you if you don't follow convention, just because it'll be harder and harder for you later on if you try and go against that type of convention. So just to make things a little bit easier, let's just do it like this. So what I want to do is draw a graph here, and it's not super important that I draw to scale, but I will actually try to kind of like get it to scale just to make it look a little bit a little bit neater, a little bit nicer. So here I will measure the prices out according to like these lines, just kind of like what I did in the previous chapter, right? So starting, of course, at the origin with 0, and then goes up to 2, and then 3, 4, 5, and 6. Now quantity is on the x-axis, and I don't have like the vertical lines to help with this. I mean, I could put them on. There's an option for it in OneNote, but I'm not going to worry too much about that. Again, drawing to scale is not super important. I'm just going to try and get the general shape of it all to work out here. So at $6, how much did customers want to buy again? $6 is 120. And then down to 0 is at 300. Okay, so let's just draw it kind of like this. Okay, and here I'll just plot the little points. There we go. So, kind of like before, each of these individual points that I plot out on this line represents the specific points according to a table here, right? So I'm not like labeling all of these here on the x-axis because again, that's not really the point to draw everything to scale or anything like that. But basically, the point that's right here, that's at $6 and 120 bags of chips. The point right here at $5, that represents 150 bags of chips, and so on and so forth, right? So that's what each of these little dots on this line represents. And then all the points in between represents all the other possible combinations, right? So like, well, what if the price of a bag of chips was, say, not $3 and not $4, but let's say $3.50? Then that would be represented halfway between the 3 and 4 mark here, right? So it'd be about right there. About right. Let's see if we can actually. There. It'd be like right there, right? So that's what the line represents. All the other possible possibilities of, all the other prices that the store could charge for a bag of chips, and how many bags of chips customers would want to buy over the course of that week, depending on that price, right? So this is just like another way of representing demand for a product, but this comes with the handy little like extra bit of representing it like visually using a line rather than having like a bunch of numbers here all at once. And it also represents all the other possible combinations as well. Kind of the last thing I want to note with regards to the demand curve is that here I have assumed that the relationship between quantity demanded and price is a linear relationship. That is, it's just a straight line, right? But note that's not necessarily the case. The reason why it's actually called a demand curve and not like a demand line, for example, is because probably in most cases, the relationship between the price of the item and the quantity demanded of the item, it won't necessarily be linear. There could be a curve to it, right? It's just that the numbers I came up with and the way that I drew the line here, it just so happens that I'm assuming it to be a linear relationship. And the reason why I want to do that is just because as we get to the third part, to the demand function, it'll be easier for me to show that to you mathematically if I assume it's a straight line and not like a curve instead. But again, just note that in practice, like in real life, if we could gather a bunch of data on the demand for certain items, it's probably not going to be a straight line. In all likelihood, it will be a curve instead. But, this is our first time working with this model, so it's easier if we just assume it is going to be a straight line. Um, and last but not least, note that this line also has a negative slope, right? It's going down, right? It's sloping downward. And that is, of course, due to this idea, the law of demand, right? As the price of an item increases, quantity demanded decreases, ceteris paribus. So that means as the price goes up, right? So for example, if we start at $1 here, then it goes up to 2, as we can see, quantity goes down because we're moving further left on the axis, right? Implying, of course, lower quantity here on the left. Um, so yeah, that just about sums up the demand curve. Now let's move on to the demand function. Okay, so the demand function. So basically, like I said from before, I want to represent the demand for bags of chips at the store using an equation, right? Demand function is representing demand using an equation. So how can I do that? Well, fortunately, because of the way that I assumed, you know, the relationship between price and quantity works out. I assume that was a linear relationship. That means we can basically just use the y equals mx plus b form to represent this straight line, just like what we did with the budget constraint, right? Because, of course, if you remember from chapter 2, any straight line can be represented by using the y equals mx plus b form of an equation, right? So that's what we want to do here. Now, of course, with the price being here on the y-axis and the quantity being measured there on the x-axis, what I want to do is not like specifically formulate it in the y equals mx plus b form, right? So we want to use the y equals mx plus b form. But because the price of the item is on the y-axis and quantity on the x-axis, we'll just substitute whoops, that's how you spell substitute. Substitute P for price for y and quantity demanded QD, like big Q little d, for quantity demanded. Okay, so then how do we actually and we'll still use m for the slope and b for the y-intercept. So those two things are fine. It's just we're putting p in for y and qd in for x. So basically it will look like this. P is equal to m qd plus b, right? Price is equal to the slope m times quantity demanded qd plus the y-intercept. Okay, so how do we actually turn like this graph, for example, or this table into this type of equation? It's quite easy. We basically just do the same things that we did from before with regards to the graph, kind of like what we did um, with the budget constraint. We pick any 2 points on the straight line, and then we can calculate the slope, right? Fortunately, we know the points on the straight line are given in this table. So we can actually just pick any 2 rows of the price and the quantity here on the table and use that to calculate the slope. So remember that the slope is rise over run, right? So in our example, in the bags of chips example, let's just use these first two rows here as our x and y coordinates. Remember, the rise over the run is just the difference in y coordinates, y2 minus y1 over x2 minus x1, or in the case of this, right, because we're working with demand, we're dealing with prices and quantities, then it will just be QD uh, P2 minus P1 divided by QD2 minus QD1, right? So we just pick any two rows, pick any two rows in the table, or any 2 points on the graph, to get price and quantity demanded. So let's just pick these first two rows of information here. So the price is, if the price is $0, quantity demanded is 300. If the price is 1, then quantity demanded is 270. So that means our slope, or M, is going to be 0 minus 1 divided by 300 minus 270, right? Because in this example, our P2 and QD2 comes from the this first row here, right? $0 and 300, right? So that's price 2 and quantity demanded 2, and price 1 is going to be $1 and quantity demanded 1 is going to be 270. So just make sure it's in the right order, right? 0 minus 1 and 300 minus 270. Then if we get that, what we end up with is -1 in the numerator and 30 in the denominator. So in other words, m is equal to -1 over 30. Okay, so that gets us the slope. But then how do we solve for b? As we can see from our graph, right, the demand curve or demand line, the demand curve doesn't reach all the way to the y-axis, so we can't just check our graph to see where that is, right? Another way is just check to see where quantity demanded is 0 on the table, right? Because if the quantity demanded is 0, then of course that means we're on the y-axis and we can check what price that is. But unfortunately, our table doesn't go that far, right? It doesn't show us when exactly our quantity demanded does become 0. So there's a couple of different ways that we can show this to solve for this mathematically. Now that we've calculated the slope, then essentially, right, what we have is the price is equal to -1 over 30 times QD plus B. What we want to do is find out what B is. Well, one way we can do that is, since we know that B is the y-intercept, right, then what we can do, okay, so that's how we can get the slope. And again, here I just use the first two rows here on the table, or in other words, the top 2 points in our graph here to calculate that. But you can use any two rows of information here. Like for example, the first row here, 0 and 300, and the last row here, 6 and 120, right? So you could do that as well. And as long as you did the math correctly, you should end up with the same slope, no matter which 2 points you choose. So that's how we get the slope, but how do we get the y-intercept, b, in our y equals mx plus b form, right? So right now what we have is, so far we have price is equal to minus 1 over 30 times quantity demanded plus b. So how do we find b? Well, now that we have calculated the slope, finding b is actually pretty simple. What we can do is, since we know the slope here is minus 1 over 30, and it's a straight line, so it's the same slope no matter what part of the curve we're on, what part of the line that we're on, then that means all we have to do is pick one of these rows of information to substitute into our equation, and then we can just solve for b. So just to make sure it's clear what I mean by that, uh, first all we have to do is pick one row of data here for the price and quantity demanded. To make things a little bit simpler, I'm going to pick the first row. That's going to be handy because the first row has $0 in here, and it's going to be nice to have a 0 in there. Makes things a little bit easier. So I'm going to pick this first row of info here. So price is 0. If the price is 0, then quantity demanded is 300. So let's go ahead and substitute that into our equation here. So substitute P is equal to 0 and QD is equal to 300. And here in parentheses, I'll say this is from the table. You can also find this on the graph as well. If I had labeled the x-axis here, right? If I labeled this out, then this would be 300, right? So we'll substitute that into our equation here. P is equal to minus 1 over 30 times QD plus B. Then solve for B. Right? And it's just that simple. So the price is going to be 0, right? So I'm just taking the P, replacing it with a 0, and that's going to be equal to minus 1 over 30. And then QD, instead of QD, that's going to be 300, right? So that's times 300. I'll put that in the parentheses, just to make sure, the 0 was being substituted in as well. I'll put parentheses around that, plus B. And now all I have to do is solve for b. So I have 300 basically divided by minus 30. So that is going to work out to be minus 10. So I have 0 is equal to minus 10 plus b. Then I will add 10 to both sides of the equation to solve for b. And then, of course, what I have is b is equal to 10. Right? So that is how I solve for b, right? It's really just that simple. So the demand function, the final form of the demand function is price is equal to minus 1 over 30 QD plus 10. Okay, so that's how we can represent demand purely mathematically using an equation. Those are the three ways we can represent demand: an equation, like this, the demand function, a graph, the demand curve, and a table called the demand schedule. But that is it for this video. In the next one, we'll pick up learning about supply. So I'll see you in the next one.